I have 3 degrees from MIT, all of them in electrical engineering, from bachelor's to PhD. When I started working, I mainly worked on theoretical physics, charged particle beams, relativistic electron beam converting to radiation, and I worked in Naval Research Lab and then at NIST, National Institute of Standards and Technology. And then in 1996, I started a company, and I decided to not be in the field of physics, but to do something totally opposite. Instead of theory, I do make things. And then I converted to working in biology, utilizing some of the techniques that we developed earlier in the company. We now have a test that it's a blood test for early detection of cancer. When cancer detected early, it's potentially curable. There's a great need, and what we have is not just a test for one cancer, but all solid tumors that include breast, prostate, colon, lung, and pancreatic, all the major cancers. This test can be used to monitor treatment and determine if there's residual diseases. And we have also many other assays developed related to cancer diagnostics. Cancer is one of the major causes of death. 43% of men and 38% of women get cancer sometime in their lifetime. It's predicted in 2017 there will be close to 1.7 million new cases of cancer, and 600,000 will die from cancer. There are about more than 40 million cases of people have cancer and is under treatment or in remission. Early detection is very important because if you can detect in stage 1, there's a potential that you can cure the cancer either through surgery or some treatments. Later stages of cancer is when that's very difficult to treat. It's when cancer spread to other parts of the body, and the drugs can make people live longer, but it's probably not curable. We collect cells from the blood of cancer patients related to cancer. And we did something that's a little different approach than many companies. That is, we decide to analyze all the cells that we collect very accurately. In that process, we not only discover circulating tumor cells, but we found a very large cell in the blood, and that's related to cancer. This cell is 25 to 300 micron in size. You can almost see it with naked eye. Surprisingly, nobody published it, nobody studied it, and people just ignored it. And we start with our very first few patients. We analyzed the cell in all the cancer subjects. And the significance is we find the cell in stage 1 at a very high percentage, and somewhere between 70 to 80% of the time. And we've studied 14 different cancers, and this same cell is in all those cancers. We filed a lot of patents, but not all of them are being prosecuted yet. We have patents on the method to collect tumor-related cells from the blood of cancer patients. That include the filter, the holder, and the method to make the filters. And then we also patent many applications of the cells. One controversy and it's related to Supreme Court decision is things found in the body is patentable. So the cell, we don't know it's patentable, but we filed the patents and how to use them. So we'll see. And we just filed a patent 2 days ago, and that is related to using the cells we find for application of immunotherapy.